Now we move on to the next set of formulae, which are called as allied angle formulae, which are really not different ones from the compound angle results that we saw, but they are mere the special cases of those previous results. Now by allied angle what we mean is, if an angle is either added or subtracted from the standard angles like pi by 2 or pi or 3 pi by 2, then the resulting angle is called as the allied angle. So that means the angle which makes some rotation apart from the standard positions of 0, pi by 2, pi and 3 pi by 2. So how to find the trigonometric ratios of these angles? So there are two simple techniques to get the answer. The first is a mechanical one, that is, like, since we know the formula for sine of a minus b, we can simply expand using that result and we will get the answer. So that goes like this. We know that sine of a minus b is sine a cos b minus cos a sin b. So therefore here we will have sin pi by 2 cos theta minus cos pi by 2 sin theta. But we observe that cos of pi by 2, that is cos 90, is 0. So therefore entire second term will vanish, and sin pi by 2 is equal to 1. So therefore ultimately what remains is cos theta. So therefore sin pi by 2 minus theta is nothing but cos theta. Alright, so therefore that is how we derive this simple result, and let us write that result also. So sine of pi by 2 minus theta is nothing but cos theta, and this we also knew from the elementary trigonometry concepts. Cos of pi by 2 minus theta can be similarly shown to be equal to sin theta. Now sine of pi by 2 plus theta, once again we can go ahead and expand, but I will also explain another interesting way which is much quicker practically. So by sine of pi by 2 plus theta, we visualize as follows. Let us consider some convenient acute angle denoted by theta. It doesn't matter whether theta is acute or obtuse, but for the sake of convenience, let us think of it as an acute angle. Now what is the meaning of pi by 2 plus theta? It just means that to the angle theta we have to add further 90 degrees, isn't it? So therefore we add further 90 degrees, thereby making this full angle as pi by 2 plus theta. Right? Now we have to find the sine of this big angle pi by 2 plus theta. That means if you remember that analogy of rotating vector, by sine we mean it is the y coordinate, that is the length as shown here. So clearly the triangle shown on the left side is congruent to the original triangle formed by the angle theta. So therefore whatever is the y coordinate of the new position of the tip, that is same as the x coordinate of the original angle theta, and x coordinate is nothing but cos of that theta. So hence here also we have the y coordinate of the pi by 2 plus theta angle is nothing but cos of the original angle. So therefore we write sine of pi by 2 plus theta is nothing but cos theta. But if we come to the cos of pi by 2 plus theta, now we know that cos is nothing but the x coordinate. But here we see that lengthwise this particular length, which is x coordinate, is same as the vertical length of the original angle, which is nothing but the sine ratio of theta. But with one difference, that here in the pi by 2 plus theta the x coordinate is negative because it is in the second quadrant. So clearly it will be having the same value as sine theta but opposite in sign. So therefore that becomes minus sine theta. So in this way we derive the allied angle formulae for the angles which are attached with pi by 2, either plus or minus. So we can go on and define similar ratios for the angles which are attached with pi, that is 180 degrees also. So let's take first, that is sine of pi minus theta. Let's see where that pi minus theta is present. So if you consider theta like this, then pi minus theta will be nothing but theta less than the pi, isn't it? So therefore, if you have to come back with the measure of theta. So therefore, if you see, sine of the original angle and sine of the pi minus theta will be exactly same because both are positive y coordinates. So sine of pi minus theta is same as sine. If you come to cos, then cos of pi minus theta is same in magnitude as cos theta, but it is negative in sign because it is on negative x-axis. So clearly cos of pi minus theta is minus cos theta. Now if you think of the angle pi plus theta, that means you have to go beyond pi, correct, with a measure of theta. So you still consider the original triangle in the first quadrant. You will clearly see that these two triangles formed are once again the congruent triangles. So if you want to calculate the sine of the new angle, which is the total angle is pi plus theta, the sine is the y coordinate, which is exactly same in magnitude as the sine of the original, but it will be negative. So therefore it is minus sine theta. And x coordinate is also same in magnitude as the cos of the original angle, but it will be negative because it is on negative x-axis. So therefore we have cos of pi plus theta as minus cos theta. So this is how we derive the allied angle formula.